Hello and welcome to another tutorial. We're going to continue our discussion on a native image. We saw that every platform has its own toolchain, macOS and Linux, and then Windows. Your best option is going to be to install Microsoft Visual C compiler. macOS is Xcode. You install it. If you don't want to install the entire Xcode application, you can install the command line tools that are basically the toolchains or the compilers that macOS supports, and then I will show you in the future lectures how to basically install those command line tools, right? So every platform has its own compiler, and the job of the compiler is to compile C++ or C applications to native binary. We know that all the operating systems today, like macOS, Linux, Windows, they're built based on C code or C++ code. Now what I'm going to show you now is go back to our IDE, and you saw that we had 3 folders, and then each one we had a Java class. We compiled them, and then we compiled the entire application into a native binary. What I'm going to do, I'm going to create another directory called example, and then in the example I'm going to create maybe let's create an empty file. Let's call it C++ example underscore cpp, and then or just example.cpp. This is going to be a C++ file, and here I'm going to, first of all, we want to write a quick C++ program that writes the same things to the console, hello world, and then print some number. And then the other thing that we want to do, we want to check whether our basically toolchain, platform toolchain, in this case the compiler that comes from macOS are installed and ready to go. So if we type C++ -- version, it points to the Apple Clang toolchain, and then it tells us where it can find the installation directory, which is this one. It's in the Xcode app, right? When you install the Xcode, and then these applications, the tool chain comes with it. Same with G++ -- version, same thing. You see they point to the same location, which means basically when you install the Xcode and the command line tools, all these aliases are generated automatically for the compiler, macOS compiler, right? Apple Clang. So what we're going to do, we're going to so right now we are in this example. So let's type some code. Let's include the IO stream, and then we're going to say that int main. We know that main in general by convention is going to return 0 on success. It's not necessary in modern C++. So basically when successfully terminated, return 0, right? In Java, they try to make it simpler, so the main actually doesn't return anything. Its signature is void. In C++, it's main, but it's int, but you don't really need to return 0, right? So that's just kept by convention. All right, now what do we want to do? We want to say in the IO stream, we had the std namespace, so std cout, which means console out, hello world from C++ application, and exclamation mark, and then a \n character, and then std cout 5, right? And this insertion operator is overloaded for the console output stream, so it understands the types, so it's aware of the type. 5 is an integer, it knows how to handle it and convert it to a string. And then let's also add we can also add a \n for the new line character. So we save this, we go back to our terminal, we say that G++ example.c -out, the output file, let's call it my app. So let's see if this works fine, and as you can see, everything worked fine. If we do a ls, you see that my app is generated, and it doesn't have any extension, which makes sense. We said that executables on macOS and Linux, they don't have any extension. And then and this asterisk means this is a binary application, it's executable, and it has the permission to be executed. This asterisk, note that I'm running fish, which is friendly intelligent shell, on top of my macOS terminal. That's why it has more intelligent features like color highlighting, and then this asterisk that tells me that this is an executable which has the permissions to be executed. If we list the files with the long details, it tells me that my app has the X permission. And in the previous lecture, we saw that how we can give a binary application executable permission, right? Or we can remove this with the chmod, right? Now that I have my app, I can execute it. And we said that in Java, if you want to launch a Java application with the JVM, you specify the name of the class that has the main, and then the path to that class is specified in the directories that are in the class path. For C++ or executable native binaries, it's not the case. You just specify the path to that file. Right now, my app is in my current working directory, so I can specify the relative path, and then enter, and then it says hello world from C++ application and file. So we successfully compiled our C++ application source code to a binary application for this particular platform, and we were able to execute it, right? So if I go back and execute that hello world that we created by compiling our Java application to native binary, I have to go one level up and then say hello world, right? And hello world from Java application 5 car machine. All right, so everything works fine. If you I can also quickly show you how to, for example, create a car object. So we can declare a class car, right? And then know that we have to terminate with semicolon here, and then we're going to say that so we're going to here our car had the int price, so int price, right? And then we're going to have a public constructor car that takes an int price, all right? And then we're going to have an initializer list to say price. So, and then our constructor is empty, right? So it's better to initialize your fields using the initializer list instead of in the body of the constructor. Whereas in Java, you don't have that option, right? Everything has to be inside the body of the constructor. That's fine. And then we want to overload the output stream. So basically what we want to say std cout, and then we want to create a car instance, right? So we want to say car allocated on the stack with a let's say how much was the price here, 100. All right, and then we want to say std cout and then push car to the to the console, and then this. Obviously, if we do this, if we try to compile, it's going to fail on compilation, because right now the console cout object, it doesn't know how to handle a type car, right? So if we say g++ my app, and then it's going to give us error, and the error is going to be complicated. Let's go back up. It says that I don't know what to do with this car. Candidate function not viable. No known conversion from car type to const void. Basically this is trying to convert to the character arrays, right, for the strings. So what we're going to do, we're going to overload the basically cout operator, right? So, and you have to do it globally. So overload the cout operator for car type. Now in Java, things are much easier because every object has the potential to be converted to a string. Know that when we do this, when we send a car type to a print line, it calls the overloaded function that actually basically it calls the to a string, right? So this behind the scenes, this gets converted to a string, and then basically this is equivalent to saying car.to a string and pass that a string to the print line, to the console. So this call to the to a string happens behind the scenes, and the reason it's implicit because all the objects inherit from the object class implicitly, and therefore they all inherit the to a string method, right? So the to a string method, the object class provides a default to a string implementation, but then you can override it in your own classes. In C++, types like classes, they don't inherit from any other type. So really there is no implicit inheritance here, unlike Java where every class has implicit inheritance from object class. And therefore you have to manually overload the to a string. So we're going to return a std stream, and then by reference, and then operator insertion, right? And then we're going to take that std stream with reference, let's say cout, and then we're going to say car by reference. We don't want to create another copies. And then obviously at the end we're going to return the OS cout again, this output stream. But then before returning back by reference, remember that these couts, these console outputs, are not copyable. So you have to only take them by reference. You cannot take them by value, because when you take them by value, a copy is generated, and copy constructor for the output streams for the console output is a deleted function. So we're going to say that cout card, basically what did we do here in the car? Basically we're going to do the same thing. Obviously in C++ there is no for, so we have to break this down into smaller pieces. So this is one piece, and then we insert the price, and then we insert a bracket again, right? So this is basically the same thing, and then semicolon. So let's go back and see if we can compile our application again. And now it doesn't work. It says that okay, so this is car.price, and know that this is by default this is private, so we cannot inherit it. So we can either make it public or create a getter. So we're going to say that int get price, and then and it's a const function because it doesn't modify. Usually getters in C++ they're defined as const because they don't change the state, right? In Java there is no such thing as const method, but in C++ you can declare them as const. And here we can say car.getPrice, right? And then everything works fine. Let's go back and compile one more time. Where is that? Is there a semicolon missing? cout, okay, return cout, yeah. Okay, one more time. And now everything works fine. All right, and then now we can say my app executed and car price then, right? And again, if we go back, say hello world, this is our executable binary, native binary that came from compiling our Java application. And hello world from Java application, hello world from C++ application, 5 car price 100, right? So as you can see, there are differences in Java and C++. Java development is much easier because you just right click and then source override to a string method, for example. In this case, because we're not using Eclipse build system, it doesn't find the necessary stuff. But in general, using an Java IDE makes your development much faster. Obviously, there are also good IDEs for C++, but the fact that if you define a class and if you just want to push it to the console output, you have to do extra work by overloading operators, because this class doesn't really implicitly inherit from some other class that provides an implementation or default implementation. That's why you have to do extra work here. It gives more control to you. You have to know that console output is not copyable. You have to always pass them by reference, and then in this case we don't want to create a copy of the car object, so we're also passing by reference, and then you have to return the console output again by reference so that you can cascade or chain all these operator calls, right? So these are basically examples of how we can compile a C++ application to the native binary. And then previously we saw a quick example of how to compile and how to compile a Java application to Java binaries .class files, and then how to then compile those .class files into operating system or platform binaries or native binaries, right? So there's a difference between Java binary, which are the class files, and native binaries, which don't have really any extensions. They're fully compiled and ready to be executed, right? And then when you want to execute a native binary, you just give the relative path or the full path on where they are on the hard disk, and the operating system knows. Before obviously executing this, operating system checks the permissions of the files to make sure that they are allowed to be executed. Otherwise the operating system doesn't execute them. So if you go back to the PowerPoint, What is the command line argument? We said that we run applications with the terminal, and terminal is a text-based application, and any application, obviously you wanna pass, the user wants to pass some argument to them, right? So that the application behaves differently based on the parameters that you pass or the arguments you pass, right? The C++ compiled binary applications, the main is the entry point to the execution. And same with Java, right? We know that in both in C++ in Java, if you are trying to create an executable application, then you have to have a main method. Now in the more general sense, it's not necessary that the entry point to your application is main, right? In Java, it's mandatory. In C++, it's not that much mandatory. But it's a strong convention, and I recommend that you always follow this convention. Some compilers make it mandatory, other compilers may not make it mandatory. You may be able to define a command line flag for the compiler so that it knows which function is the entry point to your execution. Some compilers make it mandatory. For example, Apple Clang, it makes it mandatory that main is the entry point to the execution. Static and dynamic libraries don't require a main entry point. Same with Java. If you're creating just a library, so some functions that can be used in another cases, then you don't need to have main method, because your goal is not to create an executable binary. Your goal is to create an archive binary, a binary that has some function declarations and implementation, but you cannot execute that file, right? So the C++ main, the signature is int main. And then you can decide whether you want to take arguments, command line arguments or not, right? And if you go back here, you see in my main method, I decided not to take any arguments, right? So if I go back here and try to say my app hyphen or some value, let's say hello, it just disregards this because this doesn't mean anything to my application, all right? Now, if we say, if you want to accept command line arguments, you have to declare argc, the count of the arguments, and char star, for example, argv, right? Something like that. Or you can say an array of characters. So this is a two-dimensional array, right? Which means an array of strings. So array of strings is basically an array of characters. Right? An array of characters is a string, and then you have to take an array of strings. So if we save this, let's see if we can compile. It's G++, and it compiles fine, right? But again, if I launch my application, it works, but it disregards this command line arguments because I'm not using as it. So let's check the check the command line. Check the command line arguments in C++. So let's say std cout, and then let's create some separation here, \n, and then std cout, we're going to say argc equals, and then argc. This is the count of the arguments, and you will see that actually the count is it also counts the name of the application, right, as the argument count. So this is the argc, and then std cout, we can say that let's say int or basically size t, length is basically, so we have a character array, so we can go through this. We need to know how many elements this have, right? So there are different